Bismillahirrahmanirrahim. My name is Kainat Abbasi and my roll number is 16TE83. In the second lecture of DSP, we learned about the importance of digital signal processing. In this lecture, we will learn about systems and basic signals. What is a system? That creates an output signal from an input signal, or we can say algorithm, technique or process to produce or create other signal. System process input signal to output signal. For example, x of n, let's say this is the input to a system and it gives some output, let's say y of n. For example, y of n is equal to x of n plus x of n plus 3. This is the simplest example of a system. Now moving towards the types of systems. We will discuss three types here, that is causal system, linear system and time invariant systems. What is a causal system? Causal system is the system that depends upon current and previous values. For example, let's say y of x is equal to x of n minus x of n minus 1. This is the current value and this is previous value. So causal system is a system that depends upon current value and previous value. And what is a non-causal system? Non-causal system is a system that depends on future value. Y of n is equal to x of n plus 3. Plus sign indicates it is a future value. Second type, linear systems. Linear system is the base of digital signal processing. What is a linear system? Linear system is the system in which superposition theorem holds. And what is a superposition theorem? Superposition theorem depends on two properties. Number one is homogeneous property and number two is additive property. What is a homogeneous property? If x of n is some input and after passing through a system it gives an output y of n, and after scaling that input, let's say k is the scaling factor. If input is scaled with k, then after passing through a system the output must be scaled with k. This is homogeneous property. And what is additive property? If x of n is some input and after passing through a system it gives the output y of n, x1 of n and y1 of n, and x2 of n is another input and after passing through a system it gives y2 of n, then the summation of both inputs x1 of n and x2 of n after passing through a system gives the summation of both outputs y1 of n and y2 of n. This is additive property. And a system is linear when both of these properties hold. We can simultaneously write alpha x1 of n after passing through a system gives alpha y1 of n, and beta x2 of n after passing through a system gives beta y2 of n. So when both inputs are applied simultaneously to a system, they will give both outputs, summation of both outputs. This is known as superposition theorem. If the superposition theorem does not hold, that is if linearity and additive property does not hold, then the system is non-linear. If only one property holds on a system, then also the system is non-linear, does not hold. Moving toward the third type of system, that is linear time invariant. What is time variant system? Time variant system is the system that depends on time. For example, y of n is equal to x of n whole square. This square depends on time. And what is time invariant? That is the system that does not depend on time. For example, if x of n is some input to a system and y of n is the output, and x of n is shifted by s, let's say, y of n must be shifted by s, then the system is time invariant. And our second thing, that is basic signals. In the previous lecture, I told you what is a signal. Signal is something that carries information or that change with respect to some independent variable like time. Basic type of signals: unit impulse and unit step. Unit impulse is most important in digital signal processing. We can say, what is a unit impulse signal? That gives value 1 at t is equal to 0 or n is equal to 0. Otherwise it is 0. We can say delta of n, this is the representation of unit impulse, is 1 for n is equal to 0 and is 0 otherwise. And what is unit step? Unit step only exists for t or n greater than 0, and we can write u of n, representation of unit step, is equal to 1 for n greater than equal to 0 and is 0 for n less than 0. And what is the relationship between these two signals? That is, what is the relation between unit impulse and unit step? If we take integral of unit step, what we will get is unit step, and if we take the derivative of unit step, then we will get unit impulse. And linearity, that is linear systems, and unit impulse signal is the base of DSP. In this lecture, we learned about some basic types of systems and some basic signals. Thank you very much.